Hey guys, Mr. Bowman here. Today's learning objective is in orange, and we are learning to find the area of a circle. So that's the key thing that we're looking at, area of the circle. And before we get into the actual maths behind things, there's a couple words that we need to be aware of and what they mean. So I'm assuming everyone knows what a circle means. So that's the first key word we need to be aware of. And from there's a couple other words we need to be aware of. So if you go to the center of the circle to the outside of the circle, sometimes we refer to that as R, but that's the radius of the circle. And that goes from the center to the outside edge. And the next one we need to be aware of, so I'm drawing another circle, and again we've got our center point, but if it goes from one edge through the center all the way to the other edge, that's often referred to as D, or the diameter. And it goes from the edge through the center to the edge again. So hopefully that makes sense. And the relationship between these two is one diameter is always equal to 2 lots of the radius. Or another way to think of that is 1/2 of the diameter is equal to the radius of the circle. So that's our initial point. I'm just going to change pen colors. I'm going to change to yellow. And we're going to get into some questions. And we will need to apply most of what we did here. So the formula that we're going to use, the area of any circle is always equal to pi r squared. And the key bit of information, that formula specifically refers to the radius of the circle. And that's why understanding the radius and the diameter and the relationships between them is really important. So let's start off with one question up the top here. So I've got a circle, and there's the center, and there's the radius all the way to the edge. Actually, I'll draw it going somewhere else. And let's say that there is 5 centimeters long. How would we calculate the area of that circle? And once we get into them, it is relatively straightforward. So we would start off by writing our formula. So the area is equal to pi r squared. And in our case, we know the r value is going to be 5. So we're going to go pi times 5 squared. I'm going to calculate the 5 squared first because we've got to follow BEDMAS. So that's going to be pi times 25. And then when we put that into our calculator, 25 times pi, that's going to get us to 78.5. And before we move on, we need to make sure we have the right units. We're dealing with centimeters squared. And I did round that answer to 1 decimal point because it did go on for a bit longer. So hopefully that first example made sense. Let's have a look at another example. Okay, example 2. So we've got our next circle. And this time around, let's say our radius is 11 meters this time. So again, we start off with the same thing. So the area is equal to pi r squared. We then put our r value. So we know that the radius is 11. So that's pi times 11 squared. We're then going to calculate the 11 squared first. So 11 squared, I use my calculator. That gets me to 121. So pi times 121. And when we do that, that gets us to 380.1. And in this case, our units is meters, so it's going to be meters squared. And that there was rounded to 1 decimal point. So I'm going to change pen colors now, just because we're going to look at a slightly different kind of question. So question 3, we've got our circle, and we've got a center, but this time around, we're going to be given the diameter. So let's say that diameter there is 20 millimeters. We then start off with the same process. So area is equal to pi r squared. And the issue is we haven't been given an r value. So what we need to do is we need to find the diameter and we need to half it to get to the radius. So half of 20 is going to be 10. So that means our r value is going to be that 10 millimeter radius. So that's going to be pi times 10 squared. We're going to do the 10 squared first. So 10 times 10 is 100. So that's going to be pi times 100. And when we put that in our calculator, so 100 times pi, that gets us to 31.4. And in our case, that's millimeters squared, because those are the units we're given in the question. And again, that was rounded to 1 decimal point. And the last question we're going to look at, we'll do another one where we're given the diameter. So here's our circle, here's our center, and let's say our diameter is 30 meters. Same deal, so the area is equal to pi r squared. And just remember, we need to deal with the radius, which is 1/2 of that, and 1/2 of 30 is actually going to be 15. So our radius is 15. So pi times 15 squared. We're going to do the 15 squared first. So 15 squared, that's 225. Pi times 225. And when you put that into your calculator, you're going to get 706.9. And that there is meters. So we're going to do meters squared. And I've rounded that to 1 decimal position. So well done if that made sense. So what I'm going to do is we're going to finish off with one extension question, and then I'll let you pause the video and we'll get into heaps of practice after that. So I'm going to clear our working. So if you haven't got these examples down and our notes with our formula, make sure you get them down. Okay, guys, we're going to finish off with our extension question. We may throw in another one at the end. So let's say I've got a circle, but this time around, 1/4 or a chunk of it, so that chunk there has been taken out of the circle. How would we go ahead and find the area of this? So let's say we know that there is 8 centimeters. And we know that this point here is the center of our circle. So in this case here, we've actually got 3/4 of a circle. And we're going to use that information to find out the area of our circle. So first step, well, let's go ahead and find the area of this. So the area is going to be equal to pi r squared, which is equal to be pi times 8 squared. And we're going to do the 8 squared first. That's going to be pi times 64. And we're going to plug that into our calculator. So pi times 64, that gets us to 201.1 centimeters squared. And I rounded that to 1 decimal point. And the only issue is this here is an entire circle. That there is a whole circle. So what we need to do is we need to times the area by 3/4 to get 3/4 of a circle. So 3/4 times 201.1. And that was from our area above. So when we do that, so 201.1 times 3 divided by 4, that's going to get us to 150.8 centimeters squared. And that there was rounded to 1 decimal point. So hopefully you found that little extension question interesting. What I'm going to get you to do, make sure you get the example down with our working. If you've done that, let's get into heaps of practice now. Thanks for watching, guys.